And the next presentation is making digital lab a reality at Novartis with ZONTAL.
All right, so my name is Ram Heffeli. I'm jointly presenting here with Olivia and Wolfgang. We're happy to present to you our approach to scientific data management and the use of semantic technologies and allotrope in this context. Before going into the solution design and most importantly the demo, let me share with you a bit the broader business and IT context for all our activities. What you see on this slide is the vision that was jointly defined by the business and IT leadership team for data and digital. And as you can see, across the organization, and we call it internally technical research and development, it's more known as a CMC organization in the industry. So for that whole organization, we clearly see that data and digital technologies are a key element to be successful. But we also see the people side of it. It's not just about deploying technologies, it's also about how people are using these technologies, how savvy they are, how skilled they are, and what mindset they have to manage data and digital technologies. So let's look a bit closer on the next slide now on what the people are doing. And here you see a scenario which is quite typical for many people, whether they're working in a lab or in a pilot plant or in the clinical supply chain. Most of the people have to deal with multiple systems to use for transactions, but also to consume data, to get information about the project, about the process, about the work, to take decisions, to run the experiments. And here there is on one hand a clear a challenge and a pain point with all the efforts that it takes to do that in a fairly manual way and on a system by system manner. But there's also the opportunity that we can really leverage the data in a very different way. We can automate a lot of the activities. We can be more predictive by learning from historical data. And we can really also look into a more digital first mindset, which allows to really change the way of working and do a lot more in silico experiments and activities first before going into the resource intensive experiments and activities consuming real material and equipment. The next example or situation is knowledge. I mean, that is the core here of developing a product, is we're generating knowledge about the product and the activities around it from manufacturing and supply that ultimately needs to go into the registration. And this knowledge needs to be kept, need to be shared. There needs to be exchange between people on this. And here too, this is very cumbersome, the way the data and the knowledge today is made available and is managed and is stored. So here we definitely see also lots of opportunities to apply digital technologies to streamline the knowledge management across the organization. Looking into operations on the next slide, there is again, and we've just heard an example before as well, lots and lots of manual activities which can be automated, where we can apply these sophisticated technologies, for example, to do image analysis or automated peak mapping here, for example. And finally, as I said, it's really across the organization. We also have the clinical supply chain that we're operating. There too, lots of data that is becoming available that needs to be captured, that needs to be analyzed in order to have an optimal supply chain and ensuring that patients are getting the right product at the right time. So with all that understanding and all these opportunities as well as challenges around data and associated digital technologies, we were developing now kind of a blueprint and a strategy which is outlined on this slide. If you take one more click, Olivia, thank you. So you see here again the holistic approach we're taking in this scenario. From left to right, we're trying to implement technologies that are made available along the entire value chain to the whole organization. Preferably, these are enterprise-wide scalable platforms. Some of them only used in the TRD context, but some of them, like the top layer here, our advanced analytics tools and so on, these are really corporate-wide technologies that we are reusing. Importantly now for the context today is what we call the vertical view here, end-to-end, and that's really where the data strategy is coming into play. And the approach we take to systematically transform data, which essentially is what we collect from the instruments, from the operations, from the equipment, as well as our transactional systems, how this is transformed into information that is following the FAIR principles, as we also just heard. And the goal here is really to make this information interoperable. It should be agnostic to the source technologies and systems and products where the data came from. It should be universally understandable and, most importantly, universally be used and reused in very different contexts, mainly then by the top layer here to generate additional knowledge out of that data, gaining new insights to machine learning, AI, and so on. So that's the overall approach, the architecture and the strategy we've applied to the technology with platforms, as well as to the data in creating interoperable data sets in our context here for scientific product information. And the next slide gives you a high-level view on the solution that we were building. You see again here that end-to-end approach from the very left and connecting to whatever data sources are relevant for a given business context. We then worked with our company-wide digital colleagues when it came to defining or applying the semantic principles to define master and reference data, to determine the data models, to define the ontologies, so that we do not only create interoperable data within TRD for the various departments, but even along the broader value chain of all of Novartis, from research through development down to commercial production, and that everyone has access to product information. And this product information can easily be leveraged and used in context with other FAIR data sets, for example, clinical outcomes that are managed by other teams. So this was an important step to be fully corporate aligned in how we're applying the semantics. And then the data becomes available through the ZONTAL product, and here what we call the TRD information management system. And then on the right-hand side, you see again the analytics tool sets that the company is making available, not just to TRD, but to every other department that is managing data. And that's essentially at the end where the data scientists then are working with the data. And with that, I'd like to hand over now to Wolfgang, giving you some more details on the solution that's been built.
Thank you, Ralph. So what are the ingredients that we need to build such a solution? So first of all, there were a lot of people involved. So within the Novartis organization, of course, we had to talk to the TRD team, like to the business and IT side, but also to the corporate IT side, to the chief digital office, really to understand the requirements from their tooling perspective, the way how they want to approach standardization really across all the business units. And then, of course, also internal on our side, we had teams from OSTUS helping with implementing the data strategy, creating all the ontologies and data models. We worked with the Accurate team, and we will have a presentation later today about what this tool can provide. And finally, of course, the ZONTAL team to put this all together. So what we see here on this picture is more than the technical view. So on the left side, we have various data sources, and these can be in proprietary format, SQL databases, JSON or XML files, or of course, increasingly also ADF files that are provided, for example, by the instrument vendors. Then we need to consider also the context. So in order to achieve the findable aspect of FAIR, we need to understand the contextual metadata information. So here we're connecting to reference and master data systems, such as SAP, for example, to get more product background information. And then we feed those contextual information together with the data from the data sources to the data processing pipeline, which in the end will generate verified data sets stored in the Allotrope data format. This whole process is secure and compliant with GXP regulations, so that this really can be used across GXP and non-GXP workflows. Then on the top, we see data models and standards. So here we use different ontologies. So for example, we use, of course, some of the Allotrope ontologies, but also we align to IDMP, for example, which is critical in the end, also from the regulatory perspective. And we also create data models here following the Allotrope design patterns. In the example that we will show today in the live demo, this is a stability and release data model that we have created here. All this FAIR data that we're collecting is then exposed via standardized interfaces, which makes it really easy for data scientists to consume those data sets. So we provide SQL, Sparkle, and ADF as interfaces here. And what's really then interesting from the data science perspective is that they don't need to understand all the details of how the ADF works, so they can directly work with SQL queries. They don't need to understand all the details of how all the data was collected and aggregated and processed. So it's really a very easy consume set of data assets here that we can provide in that platform. And then we have different types of consumer applications. So we can feed the data back into the business process. So for example, if we want to orchestrate the communication between instrument and lab informatics systems, we can use the standardized representation here to support this integration. We can integrate with data visualization applications or advanced AI and ML platforms. So with that, I would like to hand over to Olivia, who will do a live demonstration of the solution.
Hi, I'm Olivia. I'm a data scientist at Novartis. So I will now demo how a data scientist can use the Digital Integration Hub to go end-to-end from the data layer to generating knowledge for our TRD associates. So we have a concrete problem here, which is we have an analytical project leader, and she's in TRD Novartis. and she has to regularly trend stability data to understand the behavior of a batch. So for example, she has just received her last time point result, and so she needs to make sure that it's in line with all the previous points. Currently, the way that she does this is that she enters information from various different systems into an Excel sheet manually. Clearly, this is not the best way to deal with her data. So what I can do here is leverage the digital integration hub to help her do it more efficiently, and also in a way that more clearly protects the data integrity. I'm also just talking about one specific problem here, but the vision is that the kind of tool I developed here as a dashboard is something that can quickly be scaled to answer various different problems for various different associates. So we have already ingested most of our LIN system and constructed a semantic layer around it. Now I can pull the verified data through an SQL query, do a little bit of cleaning and data science magic, and now we have a dashboard, which is a web app, easily accessible to any associate. Now this way, the analytical project leader, any analytical project leader, can navigate the data and understand the behavior of the product she's developing. So let me show you here. Here we have our different batches, so she can just, real time, we're pulling the data. She can pick her batch, and then she can select the sample condition and the packaging type that she cares about. So we'll actually select multiple sample conditions and multiple packaging types. Now, what we see, so just to be clear, so the batch would be, our master data essentially, and sample condition is some sort of reference data. And now we see how the degradation of different impurities that appear, or the percentage of different impurities that appear, and how this changes over time. And we can screen by various different conditions. We can also hover over the data and get more information. Now, very easily, we can also go from just looking at a specific batch to looking at any batch that has the same material, quickly giving context to the batch, and we can go further and just take any variant of that material. So this gives a much better understanding of the substance and its behavior. You can quickly see here, everything is in specification until you consider this one point, which actually seems to have a sample condition that's quite different from the others. So great, this is a good starting point, but it gets much more powerful when we can actually go behind just our LINS data and actually integrate other systems, such as our SAP system or our ELN. And then you have access to longer histories of the projects and also to more detailed information on the product properties. And then you can better determine the root cause of a deviation, such as this one. And what's way more exciting in the future is that you can actually use ML to learn from all of this data what risks actually exist and flag them ahead of time. So this looks pretty simple here. There's actually quite a lot of work that had to happen in the background for this to happen. So from the perspective of a data scientist, right? The first challenge is always to find and access the data. So typically I spend a lot of time looking for the right data for the task that I have at hand. So where is the data? Who can help me secure access to the data? And this requires finding the right person in my network. I have very little overview as I search. This is not efficient. What the digital integration hub does is that it enables and democratizes the access to the data. So let me show you. This is Tim's ZONTAL space. And what you can do here is you can log in at a single point, and any data that we've ingested, you have access to. Also, you can navigate, you can search through the data using the metadata. So, for example, we have searchable different sample batches, methods. Now, if I want to actually access the packets of the data themselves, I can do this through an SQL query. That's exactly what the dashboard I showed you is doing. Now, the next thing that we want to do, of course, is to actually figure out if the data that we have is useful for a purpose. So in other words, we're really talking about the interoperable and the reusable side of FAIR. So normally I need many hours and days of discussion with business and IT to understand the data and its structure. So how do you parse the data format? What is a data model? What does this property in the data actually mean? So here the semantic layer we have built around the data captures the type of knowledge that I need, and it gives me many tools to navigate it. So for example, here we can link to the GLIMS information model. This is in our data governance semantic suite, which is available to anyone in the company. And I can quickly understand the relationship between different entities in the model. So we have, zooming out, you can quickly see the structure of the LIMS model. You have on one side the release and retest, on the other side the stability, and then the shared parts. We can also zoom in on the different concepts that we have. So for example, a sample is something central to the case we're studying here. And this is a sample on the stability side that we were looking at. And you can immediately see that the attributes relevant here are the storage position, description, sample pull dates, the sample time points, which is what I plot, and the sample condition. We could also, quickly also get a definition. What is a sample? And finally, I just want to emphasize that I'm just showing you the data from one system here, but when the power of this really comes is because all these concepts and vocabularies exist across different systems. So the full power of this approach appears when we use consistent vocabularies across different data sets so that we can integrate the data and achieve a more holistic view of how we develop drugs, really powering insights. And just something to say, so we've strived to harmonize the vocabularies and the ontologies as much as possible across the company and also with external industry standards. So finally, let me show you one more element of this, which is our lookup service, Accurates. And so I can go into Accurates, and for example, you remember we had different sampling conditions. So I can look up the specific sampling condition because this is part of our reference data. It will give me a definition of this sample condition, of course. So, in this case, 40 degrees C, 75% relative humidity was not so hard to decipher, but in many other cases, it's very helpful. You can also search by the definitions themselves. So, how to conclude? This is first attempt we've shown you here, but I think it really illustrates our vision. From the perspective of a data scientist, what used to take me weeks and months can now take me hours and days. The data that I'm working with, I know has much higher integrity. And from the perspective of our project leader that we were talking about, the other associates, again, they have a huge gain in efficiency. They can quickly get a tool to serve their purpose without having to spend hours discussing with a data scientist. And also the integrity of the data they deal with increases since they don't have to cut and paste all the time. So something that's very powerful is we go from relying on individual experts or a network to shared repositories of knowledge that make data fair. We basically have self-reporting data assets. And this in the end opens up the possibility to spend all your time discussing data insights instead of discussing data issues. And I'd really like to emphasize this is not just about the data scientist, it's really about making our data fair for all our associates. Thank you for your attention.
I mean, we just had a closing slide. Maybe I can still quickly go through that one. So what the implementation of the technology, but as well as the supporting processes and tool sets really have demonstrated to us is that they're really key for the implementation of our data strategy. We are able to get the single source of verified data, and the information is available to both humans as well as systems. The whole setup is designed to be based on open standards, so that we are open to use any analytical tool sets, be it a Jupyter Notebook or Spotfire or whatever else is available. What we hear from people is really that there has been a process of democratization of data. It is now really easy, possible to access and to find information, and that's a huge benefit. So the data scientists are really saying what took weeks and months is now done in hours and days in order to get the right data sets to start doing the data scientist work. The data and the information is truly interoperable. What we couldn't see is the lookup to the ontologies and everything. So it is self-reporting, which again is a huge benefit. Before, the data scientists required a lot of information to understand the systems, the data model, the native formats, and so on. That is now almost self-describing. And with all of that, we again really see the opportunities this will bring to the organization in changing the way the organization is working, and to drive significant acceleration in the development, using the data as a true asset and the associated technologies. And finally, this will lead to more robust products, which is at the end, of course, also to the benefit of our patients. So we're definitely, with these early experiences and results and the feedback we receive, convinced that we're on the right track. There's still a lot of work ahead of us until we have all the data sources connected, all the data sets verified and made available, but we're very optimistic that we're going to be successful with this approach.
So maybe just one question, since I'm jumping in before you move on and don't need the slides for it. Could you just comment? Again, I understand your journey, and again, I'm very happy to see the early success. Could you comment on the range of domains that you see Allotrope, first of all, needing to support your mission, and whether or not you project that the Allotrope technology would be able to support you in the range of domains? As you put it, it's really to connect all the kinds of data that you're talking about connecting. How do you look at that landscape looking forward?
I mean, as I said, it's a very holistic approach, and at the end, it's we're starting here really in the lab space. That's where we have the early use cases and the early data sets around a typical system of LIMS, ELN, CDS, and so on. But we clearly also need to look into the other areas, be it in manufacturing, be it in clinical supply. So, I mean, the hope is really that we can connect all the data sets from across the value chain, and I mean, whatever is already available in terms of ontologies, I mean, we're really reusing and only create new ones where we see that there is currently a need, but for the moment a gap. And I think that's one of the experiences as well, and I think something to really share here. Even if there is not yet data model and ontology ready, that it's not a reason to not progress. And I think maybe Wolfgang can also chime in here on how we were dealing with these situations where there is still kind of some gaps from an Allotrope perspective.
Yeah, in the end, we have an incremental approach. So we use existing ontology terms where we find them. And this allows us already to publish the data sets internally. And then as more terms are defined, either by Allotrope or by Novartis or by some other bodies, then the model can be like updated with new terms. So as Ralph said, the absence of like a publicly released and standardized ontologies shouldn't hinder you from using the semantic technologies to leverage the benefits.
Great. Thank you very much.